12.6 is on surface areas and volumes of spheres. A sphere is the set of all points in space equidistant from a given point. You may remember that the definition of a circle was the set of all points in a plane that are equidistant from a given point. But now, since a sphere is a three-dimensional object, we're talking about three-dimensional space. As such, a sphere has a center, it has an infinite number of radii, chords, diameters, and tangents, just as though a circle would. When a plane intersects a sphere, and that plane contains the center, it creates what we call a great circle. The great circle separates the sphere into two hemispheres, or half spheres. Picture like a cereal bowl that has a lid on top of it. That would be the hemisphere. Here's a couple formulas to be familiar with. The formula for the surface area of a sphere is given by S equals 4 pi r squared, and the formula for the volume of a sphere is given by V equals 4/3 pi r cubed. Notice there's no formula for the lateral area of a sphere because a sphere has no bases. It's all over round. So it just has surface area and volume. So let's take a look at several examples here. Find the surface area and volume of a sphere that has a radius of 4 inches. So r equals 4, and basically I just need to plug these into the formulas. So the surface area is 4 pi r squared, or 4 times pi times 4 squared, and punching all of that into my calculator, I get 201.1 inches squared. Probably the easiest way to put that into your calculator would be to multiply all of the non-pi numbers and then multiply that by pi. The volume of a sphere is 4/3 pi r cubed. Notice that here we have r squared when we're talking about area, which is squared, and here we have r cubed when we're talking about volume, which is cubic. So that's going to be 4/3 times pi times 4 to the 3rd power, or that's going to give you 268.1 cubic inches. And again, what I would probably do is 4 to the 3rd power times 4 divided by 3, and then multiply that by pi. Okay. Another example, find the surface area and volume of a hemisphere that has a diameter of 6 inches. Well, if the diameter is 6, then the radius is going to be 3. So, surface area of a hemisphere. Before I write the formula, let's think about this. So the surface area of a hemisphere is going to be half of the outside of a sphere, plus it's going to be that circular top on it. Remember I talked about having a kind of a hemispherical cereal bowl and then maybe a lid on top of that. So it's going to be 1/2 of the formula for the surface area of a sphere, which is 4 pi r squared, okay, plus the area of that circular lid, that top part of the hemisphere, and since it's a circle, it's pi r squared. So what's that going to come out to be? So the 4 and the 1/2 become a 2 pi r squared plus the pi r squared. So this is the surface area of the hemisphere, and then this is just the outside of it, and this is the surface area of the top. So the surface area of a hemisphere is 3 pi r squared. So let's plug those numbers in. So 3 times pi times 3 squared is going to give me approximately 84.8. This was inches cubed. No, I'm sorry, squared. Area squared. Okay, so the tricky thing about the surface area of a hemisphere is it's half of the surface area of the sphere plus that circle on top. Volume is straightforward. It's just 1/2 of the volume of a sphere, 4/3 pi r cubed, multiplied by 1/2. Simplifying that, the formula for the volume is going to be 2/3 pi r cubed. The volume of a hemisphere doesn't change, you just cut it in half, and the amount that can fill that hemisphere is just half of what fills the sphere. So 2/3 times pi times my radius, which was 3 cubed, or approximately 56.5 cubic inches. Here's another example. Find the volume of a hemisphere whose great circle has a circumference of 24 pi inches. So that great circle, you might want to think of it as like being the equator on the Earth. That has a circumference of 24 pi. Now remember, the formula for the circumference of a circle is 2 pi r. So circumference is 2 pi r. So 24 pi equals 2 pi r. And I need to know what the radius is, so I'll divide both sides by 2 pi. So 24 pi divided by 2 pi gives me a radius of 12. And since I'm finding the volume here, I don't have to worry about the area of that great circle. The volume is just going to be half of 4/3 pi r cubed, or 2/3 pi r cubed, or 2/3 times pi times 12 to the third power, which is approximately 3,619.1 cubic inches. So if they give you the circumference of the great circle, you can use that circumference formula to work backwards and get the area, get the length of the radius. And our last example here says find the volume of a sphere whose great circle has an area of 55 pi square inches. So again, that great circle kind of represented by the equator, but then the area of that circle on the top is 55 pi. Okay, and remember, the area of a circle is pi times the radius squared. So if the area is 55 pi, and I have pi r squared, I need to solve that for r. I can divide both sides by pi. So 55 is equal to r squared, or r equals the square root of 55. And I'm just going to leave it like that for now. So to find the volume of the sphere, 4/3 pi r cubed, it's going to be 4/3 times pi times the square root of 55 cubed. Now when you put this in your calculator, I would probably start with the most difficult thing first. I'd do the square root of 55, enter, raise that to the third power, enter, multiply by 4, divide by 3, enter, and then multiply by pi, and you should get approximately 1,708.6 inches cubed. So in this lesson we saw formulas for the surface area and volume of spheres. It's interesting, it's all based on the radius, and there is no lateral area of a sphere because there are no flat surfaces. And the one little tricky thing that we ran into was finding the surface area of a hemisphere, because it's half of the surface area of a sphere plus the area of that great circle that's like the lid on the bowl.